All right, class. So let's build this 3 resistor series circuit in Tinkercad. All right, so the first thing we want to get is our breadboard. I'm right there now. Now there's 2 other types of breadboards that you could choose from. This one is just a larger version of a breadboard, and this is the mini. But the one that we're mostly going to be using is this one right here. It's called the breadboard. It's small, and the way this thing works is you have these horizontal rails right here that has the plus and minus sign on them. You have two down at the bottom and 2 at the top. Um, if you zoom in, you'll notice whenever you hover over one of the holes, a green circle will appear around the holes, and also a green line in between each hole. So that's letting you know that each one of these holes are connected together. And so you see right here that you have a plus and minus. So that's a visual representation of your plus and minus terminals. But without having a voltage source connected to the breadboard, this breadboard is just a breadboard. That there is no plus, positive, or negative terminal. You have to connect your positive and negative terminal to one of these holes in order to make it positive, and one of these holes to make it negative. Likewise up here. But you don't have to plug them up, make this terminal right here positive. Likewise, you don't have to make this one negative. But that's one of the visuals that this breadboard comes with. And I'll explain a little bit more as we go throughout this example. Sign up today. Score up to $300 in bonus. All right, so the next thing we want to get, hold on one second. Back to the breadboard. So if you look right here in the middle, you see whenever we hover over one of these holes, the rest of them in that same column are or have a green circle around them with a line in between each hole. And so this is an indication that these 5 holes right here are connected. So these holes right here are not connected horizontally like the ones down here at the bottom. They're connected vertically. So meaning this hole is the same as this hole is the same as this hole. All right, so let's go ahead and grab us voltage source, and the type of voltage source that we're going to be using is called a power supply. We're going to get this guy. Let's throw him over here. Now let's get some resistors. We need 3 resistors. And I'm going to show you a different way you can add your resistors. You can just simply hit Control-C, Control-V to copy and paste it. All right, and so now I'm going to rotate them by hitting R, or you can hit this rotate button right here. All right, now let's go ahead and put our resistors in here. All right, and the other thing that we need is some multimeters. And we need 4 of them. I'm just gonna hit copy and paste. Control-C, Control-V. Control-C, Control-V. or you can just hit Control V since you already have it copied. All right. So let's get some wire. It's already red, so we're gonna connect the positive side of our voltage source down here. And we're gonna turn this to black. Now let's connect the negative side. All right. And so, like I said before, the plus and minus are just visual indications of what should be positive or negative. But they don't have to be. You could very have well done. Brought this one over here, or you could have done something like that for whatever reason, if you want to do it that way. And so now this one will be your positive terminal. Although it says negative right here, this one is actually your positive terminal, and this one is your negative terminal. You could have done something like this too. Let's say that you want to come up here, and instead of connecting down at the bottom, you could connect your negative up here at the top. So there are different options of how you can hook it up. Whenever you start getting to more complex circuits, you may find it easier to configure it in such a way um, that makes it easier to troubleshoot if you ever get into those types of situations. Because the cleaner that you can make your circuits, the easier it is to troubleshoot and to find things that could potentially be wrong with your circuit. All right, so I'm going to connect it back down there. All right, so if you look at the circuit, it goes from the voltage source to the positive side of this multimeter. So let's do just that. So it goes from the voltage source, positive side of the voltage source. All right. So now we have to get it from here, and we'll just make it red. Now we have to get it from here to over here. But we don't want to just connect it just like that, although we could, and it'll work just fine. We want to utilize our breadboard in order to connect our components. So let's do something like this right here. All right. So now if you follow the circuit, it's coming from your voltage source through this jumper wire, through this connection junction right here. And now it's coming through this jumper wire to your multimeter. Now we have to get it from our multimeter to our resistor. And we're going to do something like this. All right. So we go back to our circuit. So now we have to go from we have our multimeter connected. That's going to measure our current. So now we need to connect our resistors together. We're not going to worry about the voltage, the multimeter that's going to measure the voltage, because we can just connect those up later after we have constructed the rest of the circuit. So let's go ahead and connect the rest of our resistors, and we can do something like this. And now we need to get this resistor back down to our negative terminal. I'll just make that one black. All right, so now this circuit is electrically connected. It makes a complete loop. So if you walk yourself around the circuit from the positive terminal of your power supply, it goes through here, through this jumper wire to your multimeter, back out of your multimeter, through this resistor, through this jumper wire, through this resistor, back through this jumper wire. Oops. This one's not connected. So you see, that was a mistake that I made. But if I would have kept this like this circuit would not be complete. It would not make a complete loop. So therefore the circuit wouldn't work. And just to test something out, if you want to measure the current, you'll see that is reading 0 amps, and that's because it's not connected to this resistor right here. So let's bring this guy over. All right, so now it's connected to this resistor. Now I could have very well have put it down here. I could have put it up. I could have put this jumper wire up here. Just as long as it's in one of those 5 holes. That's all that matters. All right, so one thing I want to note is some students make the mistake of connecting a wire with a wire or end of a resistor in the same hole. Although this will work and Tinkercad will allow you to do it, it is not practical because on an actual breadboard you cannot connect a wire or 2 elements in the same hole. That's the reason why you have these additional holes at the same junction point in efforts to connecting elements together. So if I see that, you will get points deducted for practicality. All right. What else? All right. So now we need to connect our multimeters to measure the voltage across these resistors. And I'm going to do something like this. All right. So one thing I don't like about Tinkercad is you can't flip the terminals. And so I try my best to keep my circuit as clean as possible, but not to have as many wires crisscrossing over top of each other as possible. But sometimes that's not always the case, and you have to get a little creative. But we want the positive side of this multimeter to be on this side of the resistor. So we have to do something like this. Um, all right, and same thing for this one. Let's see, so we want to be over here. And you can do something like this and make it look a little bit neater. All right, and the last one. All right. And so make sure that this multimeter right here is measuring current by selecting the mode. And we're going to change our power supply to 120 volts. And now, at this point, we can simulate our circuit. and get the readings. Oops, one thing I forgot to do, I forgot to change the value of our resistor. So this one should be 6 kilo ohms. All right, and then this one should be 2 kilo ohms. And the last one is just 1 kilo ohm. And notice how the resistor band colors also change whenever you, with respect to the value that you set for the resistor. That's pretty neat. All right. Now let's simulate our circuit. All right. And as you can see, the ammeter is reading 13.3 milliamps. Same thing right here. So your power supply is going to also, it has an ammeter in it as well that indicates how much amperage is being supplied by the power supply. And you have your voltage, your multimeter that's measuring the voltage across each resistor. And one thing I like about this is you can, let's see, you can do it. Nope, I thought you can make some alterations with the circuit being simulated, but you can't. All right. So that's just about it. I'm trying to think what else I need to show you. But as you can see, the multimeter readings matches up with the readings from multisim. All right. Oh, this right here. So this right here is basically what we're doing right here. We're jumping the positive terminal over to this column right here, or this junction point right here. And so essentially what we're doing is we are extending the positive, or extending this rail right here. So really, instead of it just only being 30 holes, just imagine that we are adding on 5 more holes. But we could have done something like this too. We could have taken this guy right here and did this. And that would work too, as you can see. So essentially, all we're trying to do is just trying to figure out a way to get this positive side of your multimeter connected to your positive terminal of your power supply. So that's just about it. I mean, I would encourage you to play around with a circuit like this, so that you can get a feel for um, how Tinkercad works, and also get a feel for how to construct the circuit. But if you have any questions or need my help or anything, just feel free to reach out to me. Thank you.